How can we graph the polynomial function f of x equals the negative of x minus 2 in parentheses squared times x plus 1 in parentheses? First, we identify the sign of the leading coefficient, which is negative. And we also identify the degree of the function, which is 3. Recall that an odd degree tells us that the graph has opposite behavior at each end. This information and the knowledge that the sign of the leading coefficient is negative tells us that the graph rises to the left and falls to the right. Let's find out the zeros to know if and where the graph crosses or touches and turns around at the x-axis. Recall that the y-coordinate of a graph which crosses or touches and turns around at the x-axis is 0. So let's set the negative of x minus 2 in parentheses squared times x plus 1 equal to 0. We see that the zeros are 2 and negative 1. The multiplicity of 2 is even, so the graph touches the x-axis at 2 and turns around. And the multiplicity of negative 1 is odd, so the graph crosses the x-axis at negative 1. Let's find out where the graph crosses the y-axis, because this is very simple to find another point of the graph. Recall that the x-coordinate of a graph which crosses the y-axis is 0. So let's plug in 0 for x. F of 0 equals the negative of 0 minus 2 in parentheses squared times 0 plus 1 in parentheses. 0 minus 2 equals negative 2, and negative 2 squared is 4. Don't forget the negative sign. 0 plus 1 is 1, and 1 times negative 4 is negative 4. So when x is 0, y is negative 4. In other words, the graph crosses the y-axis at negative 4. We are not sure about the graph's behavior for x between negative 1 and 0, or between 0 and 2. So let's find some additional points and evaluate the function at negative 0.5 and at 1. So f of negative 0.5 equals the negative of negative 0.5 minus 2 in parentheses squared times negative 0.5 plus 1 in parentheses. Negative 2.5 squared is 6.25. So we get negative 6.25 times 0.5, which is negative 3.125. So the point negative 0.5 comma negative 3.125 is on the graph. F of 1 equals the negative of 1 minus 2 in parentheses squared times 1 plus 1 in parentheses. Negative 1 squared is 1, and negative 1 times 2 is negative 2. So the point 1 comma negative 2 is also on the graph. Our partial graph shows that we have neither y-axis symmetry nor origin symmetry. I can tell you that the graph of this function looks like this. But if we don't know calculus, or if we don't have a graphing calculator, we cannot be sure of the exact location of this turning point. We can check whether the graph is drawn correctly using the fact that the maximum number of turning points is 1 less than 3, which is 2. Because the graph has 2 turning points, we have not violated the maximum number possible. If you like my videos, like, share and subscribe. Thanks for watching and happy learning, everyone.